Hello again. This is Math 1220 coming to you from the College of DuPage. And the title of this lecture is LSA Clarifications. As always, please be an attentive learner while watching these videos. So why am I making this lecture? Well, it occurs to me that I may have been unclear earlier in the term, and some students may not have understood, but we don't have any due date penalties for these LSAs, so I felt it would be useful to review what really is out there for you to do and what's going to be happening in the very near future. This is also useful content statistical review for the upcoming midterm exam, and as you know, LSAs can contribute significantly to your grade. So let's begin by reviewing the course content from our syllabus. So these are the general course objectives, and this is the topical outline. I've highlighted in yellow the things I consider mostly statistical. And year to date, and by the end of this next week, we will have covered all of this and all of this. So we're well on track to be where we need to be. There's 16 weeks, and we're entering week 6, so we're going to be in good shape. This will be at the end of week 6. We'll be here, or perhaps further. Now, we have had a number of LSAs, and we're going to have more announced for the first time here, and these will be due in the very near future, are LSAs 7, 8, and 9, but let's just review all of these here for completeness. So we have an LSA 1, which was the GPA weighted average kind of calculation. The LSA 2, which was dealing with box plots, histograms, actors and actresses, and stem plots actually. LSA 3, which is Chips Ahoy, dealt with the cookies. LSA 4 dealt with the chirps of the crickets. LSA 5 is craps. LSA 6 deals with the central limit theorem. And LSA 7 is family values. This deals with confidence intervals. There's a birthday problem, which is LSA 8. That deals with independence, dependence, and simple random samples. And we also will have an LSA 9 dealing with math education and hypothesis testing. And again, these last 3 are announced for the first time here. So here was the problem about GPAs. So we had a hypothetical student called Hannah who got a certificate in accounting at COD, and this is her hypothetical transcript. These are the grades she got in those courses. What was her COD GPA? And you did have to get some, you did have to dig up some data to do this, but we got some practice uploading things, and we're going to be doing that for the midterm as well. So that was LSA 1, dealing with GPAs and weighted average. LSA 2 dealt with box plots and stem plots and histograms, and dealt with actors and actresses. Now there were 2 charts really needed to introduce this. These were the data sources I told you to go to, and you did have to do some massaging of this data to do what you, the questions. And I made a simplification recommendation for you that to handle the leap years and counting, you should use 365.25 days, and that accommodates leap years, but you don't have to worry about the individual leap years. And I suggested that you can round to 3 decimal places for your answers. Again, involves getting some data and massaging some data. And what I asked you to do was answer the question, why are stem plots not a good analysis tool for the question? I asked you to construct and completely label side-by-side box plots showing ages of winning actors and actresses. And this was like in the video I showed you the calories in the chicken hot dogs versus the beef hot dogs. I asked you to construct histograms for each of those using Excel and write a coherent paragraph about what you learned from your analysis. LSA 3 dealt with normal distribution calculations and had to do with Chip Ahoy cookies. The number of chocolate chips in an 18-ounce bag of Chips Ahoy chocolate chip cookies is normally distributed. That's the mean number, and that's the standard deviation. And this actually was something done by cadets at the U.S. Air Force Academy. So I ask you a bunch of questions. What's the probability that a randomly selected 18-ounce bag of Chips Ahoy contains between 1,000 and 1,400 chocolate chips inclusive? What's the probability that a randomly selected 18-ounce bag of Chips Ahoy contains fewer than 1,000 chocolate chips? What proportion of 18-ounce bags of Chips Ahoy contains more than 1,200 chocolate chips? What proportion of 18-ounce bags of Chips Ahoy contains fewer than 1125 chocolate chips? What is the percentile rank of an 18-ounce bag of Chips Ahoy that contains 1475 chocolate chips? And finally, what is the percentage rank of an 18-ounce bag of Chips Ahoy that contains 1050 chocolate chips? LSA 4 dealt with crickets chirping and some regression analysis. You were supposed to do questions 1, 2, and 3 only. You don't have to do 4. So crickets make a chirping noise by sliding their wings rapidly over each other, and you've noticed this perhaps. And you maybe have noticed that the number of chirps increases with temperature. So here's some data. Someone actually studied this, as you can see in the Harvard University Press. This was a published paper, and it looks like it was a 9-page paper. So I ask you questions about what is the likely explanatory variable and why. I ask you to draw a scatter plot, compute the linear correlation coefficient between temperature and chirps per second, and D, does a linear relationship exist between temperature and chirps per second? Then using that data from problem 5, you were to find the least squares regression line, interpret the slope and intercept, predict the number of chirps per second if it is 83.3 degrees Fahrenheit. Here was a cricket observed chirping 15 times per second at this temperature. Is this above or below the average? It's 55 degrees outside. Would you recommend using this model that you found in part 8 to predict the number of chirps? Why or why not? Then I ask you to use the results from problem 1 and 2, compute and to interpret. There's 2 questions there, capital R squared. LSA 5 dealt with simulating the craps game. So craps is a popular casino game. In its most basic form, 2 dice are thrown. If the outcome is 2, 3, or 12, the player loses. If the outcome of the first roll is 7 or 11, they win. And any other number serves as the point. The player must roll that number again prior to rolling a 7. For example, if the point is 8, the player must roll an 8 prior to rolling a 7 to win the point. So you were to simulate 200 games of craps and submit your answers. LSA 6 deals with the central limit theorem and also the normal distribution. And it tells you that the length of human pregnancies is approximately normal with a mean 266 days and a standard deviation 16 days. So questions that I ask include, what is the probability that a randomly selected pregnancy lasts less than 260 days? Suppose a random sample of 20 pregnancies is obtained. Describe the sampling distribution of the sample mean and the length of human pregnancies. Then I ask, what's the probability that a simple random sample of 20 pregnancies has a mean gestation period of 260 days or less? And what is the probability that a sample of 50 pregnancies has a mean gestation period of 260 days or less? And what might you conclude if a random sample of 50 resulted in a mean gestation period of 260 days or less? And what's the probability a random sample size 15 will have a mean gestation period within 10 days of the mean? LSA 7 deals with confidence intervals, and it deals with family values. In a USA Today Gallup poll, 768 of 1024 randomly selected adult Americans aged 18 or over stated their positions on the family values and described them as being extremely or very important. So what is the point estimate for the proportion of adults for which it's extremely or very important? Verify that the requirements for constructing a confidence interval for P, the population parameter, are satisfied. I ask you to construct a 99% confidence interval for the proportion of adult Americans for which this is extremely or very important. I ask, is it possible that the proportion is below 70%? And then I ask, is it likely? And finally, I ask, using the results of Part C, you're to construct a 99% confidence interval for the proportion of family values that are extremely or very important in determining their vote for the president. LSA 8, the birthday problem, simple random sampling, independence, and dependence. Assume a simple random sampling that the birthdays are evenly distributed throughout the year, and that there are only 365 days in a year. How many folks would you expect to get in a room before the probability of matching birth date exceeds 50%? Just to clarify this a little bit, you would want to have at least one birthday that matched. How many folks would you have to get in a room before the probability of having a matching birth date exceeds 90%? And LSA 9 deals with hypothesis testing. In 1994, 52% of the parents with children in high school felt it was a serious problem that high school students are not being taught enough math. A recent survey found that 256 of 800 parents felt it was a serious problem that students were not being taught enough math and science. Do parents feel differently today than they did in 1994? You're supposed to use this level of significance, and this was a published article as well. Questions I'm asking you is, what are the null and alternative hypotheses? What is your statistical conclusion? And what is the appropriate wording of your answer? In closing, now more than ever, time is precious. Each day must count. Do the math. It will make you strong. And now more than ever, take care of yourself and of each other, because we're all in this together. God bless you all.